On January 6, 1992, the world's first total soil recycling demonstration facility began operations on Toronto's Cherry Street. Cherry Street is on the western side of Toronto's Port Industrial District, which is approximately 1,000 acres of land, which since the 1930s has been used for such purposes as oil refining, fuel storage, coal handling, foundries, scrapyards, and metal recyclers. Past industrial uses have left the soil with a legacy of oil and grease contamination, combined with a mixture of toxic heavy metals. Some of these contaminants we know today can be carcinogenic even in small quantities. The lack of an affordable approved technique for remediating contaminated lands has prevented the redevelopment of the Port Industrial District. The Soil Recycling Demonstration Project was established to find an answer that is economically viable and environmentally acceptable. After lengthy study, it was determined that to effectively remove contaminants from these soils, 3 separate treatment processes would have to be successfully integrated: soil washing, metals extraction, and bioremediation. This is the basis of the Cherry Street facility. Soil washing is commercially available today in Holland and Germany. Soil washing, which is the first stage at Cherry Street, is a multi-phase process that separates free oil and contaminants from clean soil and leaves about 80% of the total volume of soil cleaned. That 80% is suitable for reuse as fill on industrial lands, but the remaining 20% residue is highly contaminated. In Europe, until recently, that residue had been shipped to East Germany and dumped in landfill sites. But at the Soil Recycling Demonstration Facility, the contaminated residue is put through 2 additional processes, each of which represent a significant breakthrough in environmental cleanup technology and are successfully demonstrated in this project for the first time anywhere. The net result is that 99.6% of the soil is clean enough for reuse. After soil washing, the 20% contaminated residue is mixed with acids to dissolve the metals. The slurry is then passed through a reactor, which removes heavy and light metals in a chemical process. The hazardous metals like mercury, lead, arsenic, zinc, and copper are then removed separately and in a pure form, which can be reused or recycled as raw materials. This is a unique process developed for the Soil Recycling Demonstration Project and is protected under patents owned in part by the Toronto Harbour Commissioners. The second additional process applied to the residue after the removal of heavy metals is bioremediation. The slurry, which now still contains organic contaminants, is oxidized and then pumped into large reactors. The slurry is mixed with naturally occurring bacteria, which attack and digest the organics. These organics include oil, grease, benzene, and many more. Biological treatment of polyaromatic hydrocarbons, such as naphthalene and benzo-A-pyrene, which results from coal storage, is also being investigated. The biodegrading process in these reactors takes about 3 weeks. No incineration whatsoever is used, and there are no harmful emissions of any kind resulting from any of the processes. No contaminated soil has to be taken away and dumped in a landfill site. The fine soil particles that come out at the completion of the final stage are clean enough to be combined with the 80% that was cleaned by the soil washer and used for backfill on industrial land. However, in Ontario, the reuse of cleaned, formerly contaminated soil is not permitted by the Ministry of the Environment.
Up until now, the method of decontaminating a site, remediating a site, has been to excavate the contaminated material and to haul it to a landfill and replace it with clean fill. What our demonstration has proven is that there is a smarter way. You can actually remove the contaminants from the soil so that the soil can stay on the site for reuse as backfill on the industrial land, and we're removing contaminants in a fashion that, in a form where they can be recycled. The metals come out as pure metals. They're a metal industry's raw product. Under US EPA rules, They're delisted. They're not a contaminant anymore. We need those kinds of rules here. We don't have them yet. One such policy response has already been taken in the United States, where as of May of 1992, contaminated soils, you can't dispose of them in landfills anymore. They're saying the technologies are there, they must be implemented for soil treatment on site. You just do not put that material in landfills anymore. We don't have that kind of a policy directive here yet. One can still put contaminated material in the landfill, and as long as you can, that becomes a viable option for anyone trying to clean up a contaminated site.
This made-in-Ontario solution to soil and groundwater decontamination is capable of cleaning a wide variety of contaminants from a wide variety of soils. Its potential for cleaning up industrial sites has attracted national and international attention. The Minister of the Environment from Lower Saxony, Germany, commented on the superiority of this facility to current European soil remediation processes.
This soil processing plant for me is interesting because we have in Germany problems with contaminated harbor soil and with other dump sites which have contaminated soil as well. We are installing at the moment a lot of processing plants to clean up these soils, but we are still missing the 25% which could be cleaned up with the processes I have seen here.
The soil recycling demonstration facility has successfully reduced the level of contaminants from 4,000 tons of soil from Toronto's port industrial lands and 200 tons of contaminated sediments from Toronto Harbour. This is only a demonstration project. While it has only cleaned up 0.2% of the total contaminated soil in the Port Industrial District, it has provided answers.
What we've demonstrated here is that the solution is there. It's already here. We don't have to study it anymore. It exists.
Total soil recycling, a made-in-Ontario solution to contaminated industrial lands.